Good morning, everyone. Thank you for attending. My name is Owen and I work for Chronos Technology. So Chronos are a leading authority in resilient synchronization and timing systems. We've got over 30 years experience in GNSS, which stands for Global Satellite Navigation Systems, and that includes GPS as the main one that we'll all know. We've built up our team of technical experts who provide complete solutions from network design, installation. We also do training and round-the-clock support as well. We're no stranger to industrial park. BT have been a long-standing customer of ours, but we're still a small business. We're part of Innovation Milestone because we're an innovative technology company, and we want to grow and change. And this is the perfect place to showcase what we do. So considering our vast experience and our diverse portfolio of products and services that focus on innovation, we've teamed up with MIT to expand on our capabilities, and now we offer truly smart technology. So from the initial discussion and the propositions to the implementation and the setup, it's our goal to educate companies for them to achieve their targets of environmental neutrality, and also to improve staff well-being, safety and productivity. That's something we consider during COVID-19 as well, and we'll go through that in a bit. Today, with our smart building solution, we're allowing devices and data to communicate in a way that normally goes completely unnoticed. There are massively vital insights into understanding your operations, and a lot of businesses with smart solutions aren't seeing the correlations between the different data sources. Some are actually unaware of just how smart the buildings are. So through this breakfast meeting, we're going to show you how IoT, or Internet of Things, goes much further than Wi-Fi enabled toasters or kettles, and can be used as a tool to bring your facility and the wider business as well into the 21st century. We'll demonstrate some real use cases of data relationships. We'll show you some unique holistic overviews and some practices that make facilities management more manageable. So that's our aim this morning. At the center of our smart building solution is the use-centric software, which we're really excited to show you, and to guide you through how it works and what it's capable of is MIT's Elliott Ford.
Morning everyone, Elliott here at MIT. I'll start off by just introducing who MIT are, and I'll go through a little bit about what the use-centric solution is, and then we'll go on to a demonstration to bring it all to life. So yeah, firstly, MIT, we're a UK-based software development house, and we've been developing software for the past 35 to 40 years, predominantly for telecommunication systems to analyse telephone systems. But over the years, our use-centric solution has evolved to not just capturing data from voice platforms, but to analysing pretty much any data source. And from that, we're providing meaningful insights and reports to show companies exactly what they've got so they can make informed decisions going forward. So this has kind of led us into IoT, as Lewis mentioned, Internet of Things, sustainability, smart buildings, environmental monitoring, measuring the carbon footprint of a business, and technology adoption. So Ucentric is a centralized reporting platform, so it brings all of your data sources into one place, so you're not having to go to multiple different locations to find the data, which is obviously time consuming. Ucentric also provides dashboarding technology as well, so you can get all your performance at a glance and prioritize all of your data sources on one page and shortcut all of that. And again, it allows you to extract all of the data from all of those data sources and make informed decisions going forward. So environmental reporting, it's a hot topic that's on everyone's mind at the moment, looking after the environment, and a really good metric and report that we're providing at the moment to businesses is running analysis during COVID-19, where not much is being used within a smart building or any building at all. You know, all the appliances and assets tend to be turned off, and then running analysis once everyone is going back to the office, when there's a massive spike in people going back to the office, which is what everyone's starting to do now, which obviously leaves a spike in cost because staff are using more of the assets within the building, and obviously it's a spike in the environment and the carbon footprint as well. So Ucentric really sits on top of that and allows a company to see the differences between that. Measuring the air quality in a workplace is a key report that we're offering at the moment, and we feel it's all about offering a safe place for staff to work in, especially during the current circumstances and everyone phasing back to the office now. So we run a report called AQI, which is Air Quality Index, and it allows our sensors. We have our own sensors that we deploy within the building, and we can also extract data from existing sensors that a building may already have. And it runs analysis on particulates in the air, gases and toxins, some of which you can see on the bottom right-hand side of the image here, which can measure the air quality of a building. Just moving on to IoT. So another hot topic which is on everyone's mind at the moment is mental health. With everything being so available at the moment, you can work from your smartphone wherever you like. You can work from an iPad or a computer, wherever. It's making staff feel as if they need to be working overtime. So we're working with a law firm in London at the moment, and whereas previously it was all about making sure your staff aren't they're not underworking and what have you, they're flipping that, and they want to make sure their staff aren't overworking and burning themselves out, which is having a negative impact on their mental health. So they're using Ucentric to monitor that for their staff, which is pretty clever and quite diverse and dynamic as well. With COVID-19 as well, as you can see, we've got a 3D model of a building here, and this is tracking movement of people around a building at different times of the day. So we've developed only recently an internal track and trace solution that can track a certain individual, what time and what rooms they're walking into at a certain time of the day, and whom they may have come in contact with. Moving on to just infrastructure. So this is just sort of explaining that we can pretty much pull any data feed into Ucentric. So it could be all of CCTV feeds that a company has, so they're not having to go to different IP sites to see their CCTV. They can pull it all into Ucentric and have one centralized platform. We're also providing what if scenarios and what if analysis. So if this sensor is connected to this HVAC system or this system, and this sensor goes down, then it affects this system here, and you can provide and set up alerts and alarms that can be emailed to you, and they can come up on the Ucentric dashboard to show you these instances and to show you if this sensor's gone down, so you can quickly make a decision and to fix the issue. And just to sort of summarize my slides here before we go on to the demonstration, Ucentric is technically and commercially scalable. It's suitable for any size business, small, medium or large. It's easy to use. You don't have to be a technical genius to use Ucentric, and it's completely user-friendly. Both Chronos and MIT were flexible, responsible and agile businesses, and it comes with full support from both of us to set up Ucentric, provide all the necessary training, and to get you on your way to using the solution. And ultimately, Ucentric is there to deliver real business decisions, so you can make informed decisions going forward to becoming a greener business and to save cost. So I think it's only fair we bring this to life for you over a demonstration. Over to you, Paul.
Thank you, Elliot. Okay, so good morning, everyone. I'm going to take you through some of the key points that Elliott's just discussed. And I'll start off by saying that the idea behind Ucentric is that we can capture data from literally any source, and we really don't care what it is. Anything short of a carrier pigeon, we can log it, report on it, and provide meaningful intelligence. Although we can, deploy sensors in order to capture some of this information, realistically, we try and capture data from existing systems within any organization, because what most people don't realize is that you're often sitting on massive silos of data that aren't being touched. So I'm going to take you through some of the reports now, and let's start with, say, an environmental quality report, which Elliott mentioned. So I'm going to look at a particular day here, and I will just say that for all of this data, it's been taken from sample sets from real life scenarios from real organizations. So, it'll be from large investment banks, central government agencies, and some of it from things like the Transport for London. So here we can see that it's given us, first of all, comparison against different particulates and emissions, and giving us a quick view. Okay, so the thing with measuring all of these things like gases is, what does it actually mean, and how many parts per million means what? And because for each of the different types of emissions and particulates, there are different levels of potential harm. So what we do is we actually take these values, feed them into the EU and UK directives and the US OSHA directives, and then we give you a simple view that says, everything's okay. And you might think to yourself, well, why do I need to worry about things like, volatile organic compounds or particulates in my office? And what people don't realize is that, you think of particulates as the fumes coming out of a dirty diesel taxi as it drives around London, when some of the worst particulates and most highly carcinogenic are there in an office environment. I'm talking about photocopiers and laser printers. So being able to understand and be able to pick those up and then convert that, we can see here some particulates, and convert that into an air quality index, telling us whether things are actually okay or whether there's a problem with air quality. And in fact, one of the large telcos here in the UK were doing some studies around their offices, and they found that there was a certain office where people felt, quite sluggish all the time. And when they measured the air quality in there, they found that it was way outside the permitted levels for carbon dioxide. So being able to see all of that information in a single page gives you a better understanding of how you can monitor the entire building and also the air quality for all of the staff within. Now, some of the other areas where we're capturing data are things like electricity usage, and again, this is actually from a large investment bank in London. Okay, so this is from sensors that they have within the kitchens of this particular bank. And the sensors are provided by Centrica in order for them to provide some sort of metrics, but it wasn't particularly useful. So we captured that data and fed it into Ucentric. And from this, it gave some immediate insights which they were just completely unaware about. For instance, that the fact that their glass washers, this is a very posh bank and has a very large kitchen to entertain its clients. Their glass washers are using more energy than their grill. They also found, although I can't show it here, that a lot of the equipment was being left on over the weekend. So things like coffee machines and that, which don't need to be on standby, were left on over the weekend and using a lot of energy. But also that the ovens were being used over the weekend, and they actually found out that some of the staff, like the cleaning staff, were making uses of the kitchen when they weren't there. And this is one of the things that we often see, is that resources in an office environment are being used outside of hours or being left on when they don't need to be. And we can convert this into, this is a single day, and in a single day, this kitchen has generated the equivalent of 27 kilograms of CO2, or the equivalent of someone driving 70 miles in a car. Now they can mitigate this by recycling a bag of paper. And we're only looking at a single day here. When you start seeing in the further reports how much this suddenly ramps up depending on who you are and what you're doing. One of the key things though is building access. So we've mentioned before that IoT, people think of IoT as was said earlier, smart fridges and kettles and things like that. Whereas we see IoT as essentially, pretty much anything that's connected to the network. So that could be laptops, it could be mobile phones, it could be every printer in the building. Everything that's connected has data that we can analyze, and then we can pull that data out and then show it in a model and map it over time. So we can see here's a building. This is actually again real data from this particular investment bank, and as we move through the day, we can see movement of staff through different parts of the building. And if we scroll down, this is actually only looking at the security and cleaning staff, but we can see here where the hotspots are. Now, the interesting thing that came from this data, the particular reason for this this data capture for this particular client is they wanted to know how many people were using the cafeteria, so they knew whether to fund it and keep it in place, subsidize it or get rid of it and reuse the office space. But what was really interesting was that the other insights we got from this data, and that was this particular building is located near Liverpool Street Station. And in the morning, what we saw was everyone was coming in this lower ground entrance. And again, you can see at lunchtime. But of the evening, they were all going out this first floor entrance. And it took us a while to realise why this was occurring. And of course, it's by a station. So in the morning, everyone was coming into Liverpool Street Station, going down the steps, down to Bishopsgate, going down to Pret or any of the other expensive coffee shops and selling their firstborn child so they can afford a bagel and a latte. And then they were coming in the lower ground entrance and going up to their office. When it comes to 5 o'clock, though, they had a completely different mindset. What they wanted to do was get out the building as fast as possible and either rush to the station in the vain hope of actually getting a seat on the train this time, or rush into the Witherspoons next door for a cheeky pint before they go home and face the other half. Now, you might wonder, what use is this information? Well, the thing is, we think we're highly functioning apex mammals, but really we're nothing more than slightly smarter sheep. Neurons that fire together, wire together, and repeated actions become ingrained in our mental pathways. So imagine now that there's a fire or, God forbid, a bomb goes off. Do we think everyone's going to come down the stairs in an orderly fashion looking for the person in the high-vis jacket and the clipboard that's been there for every fire drill? Or do we think they're going to run screaming like banshees down through the stairs and out through the door, which they go out of every single night at 5 o'clock? And this, of course, causes choke points. So knowing this and understanding the movements of people around the office allows you to reconfigure your building, make lifts go to different exits and on different floors, change the way that stairwells open out into lobbies and that, so that people tend to go to different exits. And it can actually feed into the health and safety of the building and emergency risk assessment and things like that. What it also showed us from this data was that there was minus 300 people in the building by the end of the day, which of course is ridiculous. And from this, we could quickly point out that one of the exits had no swipe exit, so people could just leave the building, and also that people were tailgating on the way in. It also showed that one of the security passes was being used 24 hours a day. Now, all this data was already there. It was already in their building access system, but their building access system could basically only tell them if someone was in the building or not, or produce a massive CSV file, which was completely impenetrable. So, and this goes back again to what we're saying about U-centric, is it's taking all of this quantitative data and turning it into qualitative reporting, being able to understand what's there. Now, of course, once we've got this data from the building, we can start doing really clever things with this. So, I could look at, let's say, I could look at printer usage as an example. And let's just get the right data for this. And we can actually start combining data, though, and showing it all together in one place. And here's an example of a large office floor plan. And it gives you an idea of how much detail we could go into. So in this case, we could bring up information about how each desk is being used, what printers are being used. We can see here it's highlighted in red because that one's being used more. Even things like smart lockers, electricity points, room access. And this is the level of data that we're going down to. So, and this doesn't require any new hardware being installed inside the environment. We're taking data from the HVAC system, we're taking data from the building access system, from existing electricity measurements from Centrica, from the BMS, everything that's already there, all this data that's just sitting there. Even down to the point of being able to map performance and environment for, say, people sitting at their desk. We could look at information like sound levels measured from the handsets. Just get the right diagram. And, in a contact center or quasi contact center environment, we can then look at how noisy the environment is. So if you've got a large open plan office, we can take the data directly from the headsets to measure background noise, or you could just use standard noise sensors and again, translating this into meaningful things. No one knows what a decibel looks like. I wouldn't know what one was if it came up and bit me, but I do know what sound of the level of conversation noises, or a quiet room, or hushed tones. So being able to translate this into something meaningful, a noisy restaurant or industrial noise, it's about turning it all into useful information. Track and trace was mentioned earlier. So the ability to say, Fred's phoned in. Oh, I've just come up. I've just done a lateral flow test and I've come up positive. You might think, oh no, what am I going to do now? So let's check who he's come in contact with. So we can pull up the office building. We can look for Fred, and we can see in a few moments. There we go. We can see exactly where Fred's been in the building. And we can also see who he's come in contact with. And so we can see he's come in contact with me and Rita. But actually, the only places he came in contact with us was entrance doorways, access lanes. So, nothing that's going to cause alarm, because it would have been in passing. If it had said meeting room number 12, then, then we've got a problem, and it's best to advise these people to go home and not come into the office. And when it comes to things like the space within a building, one of the reports we've been recently asked to develop by this bank, let's just make sure I've got the right data, is room usage. So what we're doing here is taking still images from existing IP cams, or putting tiny little, off-the-shelf IP cams in rooms. And what they do is once a minute, they take a single frame picture and then count the number of people in the room using AI. So it's not retaining the images. There's no data privacy issues going on here. It's literally take a picture, count the people, throw the picture away. But from this, we can ascertain how many people, in this case, the gym, how many people were in the gym at different times of the day. Now, the way that this is being used in London is that there's a lot of space in these offices, and they cost a lot of money. £4,000 a square metre per year. And of course, with the change in business working practices now, with a lot of people projected to work from home at least 50% of the time, do the offices need the amount of space that they've got? And then you've got the flip side of the coin. I mean, if you go to a large telecoms provider in Newbury and try and get an office there, or a meeting room there, it is absolutely impossible, because everyone's preemptively booking meeting rooms because they know they're not available. So they just book them all the time, and so that just in case they might need one. So what this will do in that case is look at these rooms, count how many people are in them, and then you can see whether large rooms that hold 10 people only ever have 2 people in them, and then perhaps you can reconfigure the rooms and put up partition walls so that you can create 2 offices and reduce that problem. So you can see here, taking a lot of that information, visualizing it again into a useful way. Now, this has all been looking at the building. We can take the data from any other source as well. And here's a good example of where we've taken data, and I need to go back in time here, because this is, let's just say it's for a large, well-known indie band based out of the West Country. I can't really say much more than that. And this is their movements on their tour in July 2017. So if I look at this data, this now tells me on a Google map exactly how many kilograms of CO2 they used for, and this is just their flights and accommodation. So if I click on this, you can see, that private jet flight there, 473 kilograms of CO2 just for that flight. And we're talking about 10 band members here. As we scroll down, we can see how much CO2 is generated. And ultimately, for that 1 month, they generated 12 tons of CO2, or the equivalent of chopping down 17 fully grown trees, the entire energy usage for 1.7 domestic homes for the year. But they could mitigate that. And in fact, this is their raison d'etre for giving us this data, is because they want to actually offset their carbon footprint. And they want to know where their carbon footprint is impacting most in the world, so that they can plant, in this case, 200 trees in Europe. But when they're on tour in Malaysia, say, they want to make sure they're planting it in Malaysia, and so on. And we can again visualize these trees and say that how much space does that actually use? Well, if I zoom in here and put it in satellite view, we can see that that is how much of the Amazon rainforest they would need to replant in order to show that, in order to mitigate that. Okay, and the one last thing I'll cover is how we're visualizing other external data sources. So what we can do is we can take data source from any external API or, as I said, anything short of a carrier pigeon. But here's a good example of where we've taken Transport for London's data. So this is through their graph APIs that everyone's can use and access. What we can see here is we've got some information here on 3 of the DLR stations. But we can start blending data from other sources in here. So, if I right-click on this, there's a live feed of Stratford Station on Hitchcock Lane. You can see it's quite quiet in London today. It is live, and there's a person walking there. Or we can look at the train timetables and see how they're doing. And look at that, everything's on time. Never happens when people are actually going to work, of course, but at the moment, all the trains on the CTC are running on time, and Canning Town's going to be on DLR. So there we go, there's DLRs. But we can drill down into these stations and see all of the different aspects of them. So this is a relational diagram, and we can literally see every single element of the station. And as Elliott mentioned earlier, what we can then do is start blending in measurement data in order to provide what-if scenarios. So we can see here that this condenser unit is running a hot. I mean, I don't know what one of these is. I have no idea what an ACU split is, but I don't need to know, and nor does Ucentric, because it's data and it knows how to process and view the data. So we can see that because this has gone out of range, it's going to affect this, which is going to affect this entity, which ultimately could affect this station. Now, it doesn't matter what the data is we're looking at. This could be, plumbing systems, it could be electrical systems, it could be any form of relational data where there is a causal link between objects. So being able to see that. And again, we don't really care what that data is. We could be looking at edge switches on a voice network or IP network and actually drilling down and mapping devices, and also being able to see how things are linked together. I can see this phone is on this port on this switch, which goes back to the LAN. So it's all about visualization. And on the last aspect of that, we bring it all together in dashboards. So we have the ability here of taking all of that data that we've previously captured and showing it in dashboards. So here we've got a mixed dashboard where we're showing availability of systems. We're showing telephone call management stats here. We've got CCTVs. This is actually static pictures from the Highways Agency, and measurements. And you can have as many of these dashboards as you like, and they're all pulling data live. So, there we go. Here's a travel one. So we can see here we've got flights landed. Even though there's not many planes, they're still some of them are still late. Trains, again, CCTV. That's London Bridge, and tube maps and so on. And you can create as many of these you want. There's all sorts of different feeds we can put in here. So we can put IoT in here. We can put network. All sorts of different items, and this list is constantly growing as we add more and more IoT capabilities to the Ucentric suite. Okay, so that's covered my my demo of the system. I'll now hand it back to Elliott, I believe.
Hi, Paul. I'll take over from there.
Oh, okay, no worries.
Perfect. Well, thank you, Paul. Folks, I hope that what you've seen today shows how the core of our smart building service can extract every bit of data you should use to make your facility or workplace safer and more efficient as well. We've seen how the carbon produced is measured and also how it's put into perspective, which is really nice. We've looked at the safety benefits as well of heat mapping, the tools you can use to manage a return to work, and discovered how the visual insights as well can reveal more about your network than you previously thought. Each device tells a story, and it's about having the right tools to listen. It's also important to know that through the whole implementation of these systems, as Chronos, we really want businesses to get the most out of their networks, and we really want to make this an easy process as well. And that's whether we guide end users to really get to grips with managing their data and learn new skills, or instead, if it's to help set up this tool to do the work and push out those insights as regular updates. It's then a case of changing parameters where you want to see improvement. And so we invite you, to ask yourselves, how smart is your building? And with that, I'd like to thank you all for your time and attention, and to Nikki and Jim and the folks at Innovation Martlesham for giving this opportunity to us to share with you something that we're really passionate about. Please feel free to use our contact information on screen. If you'd like to learn more about your own building as well, we'd be really happy to help. So thanks, Jim. Over to you.